Hello, everyone. I'm Reese.
And I'm Kelsey.
And this is Charismatic Megafauna. So, Kelsey, what did you learn this week?
I learned about this crazy beast called the Greenland shark.
The Greenland shark.
Yes. This is not the first time I've heard of them.
Is this an actual shark? Or is it just like a dude and that's his nickname?
That would be cool. I'm sure there's a dude who's nicknamed the Greenland shark. But no, it's an actual shark.
Okay.
Its scientific name is Somniosis microcephalus. Do you want to take a guess as to what that means? I can repeat it for you if you'd like.
Yeah.
Somniosis.
Okay. Has trouble sleeping would be my first guess.
Okay. Microcephalus.
Small cephalus.
What is a cephalus?
You're pointing at your head. Is that?
Yeah, it's a head.
It's a small head?
Yeah.
Okay.
So somniosis is sleep, but not trouble sleeping. So it's a type of sleeper shark.
A what?
A sleeper shark, which is just a type of shark.
Okay.
And microcephalus does mean tiny head, but I've seen pictures of these guys and they definitely don't have tiny heads. So I don't know where that came from. And I didn't go that in depth for our Greenland shark. They're also called gurry sharks or gray sharks. So if you've heard of either of those, all the same thing. Now the reason they're coming up right now is because there was a study published, and it's been a bit now. The study isn't new. But there was a study published that says that this is the longest living vertebrate. It has a lifespan of at least 300, but up to 500 years.
What?
Yes. A vertebrate. Now, to put that into perspective, I think the longest living Galapagos tortoise was maybe 175, something like that.
Sure.
Regardless, even on the low end of this range, these Greenland sharks live way longer than anything else. They do not reach sexual maturity until they are 150 years old.
Sure. Like Scandinavians?
Yeah.
Yeah.
Which is interesting because they're the Greenland shark.
Yeah.
So they're very close to Scandinavia.
Yeah, that's fair.
So not only are these long living, they're also among the largest shark. They rival the great white. They are around 21 feet and 2,200 pounds.
That's
big boy.
That's big. What is like an average shark? That's a stupid question.
Yeah, sharks range pretty wildly.
Okay, so give me like a mid-range shark.
I don't know for sure, but in my brain, a mid-range shark would be like a bull shark or a tiger shark.
Okay.
And they're typically 10 feet, maybe.
Okay. And how much do they weigh, roughly?
I don't know off the top of my head.
Come on.
I was not expecting that question.
Yeah. Yeah. Sorry, it's not a quiz. Go on.
These are big sharks.
Yeah.
Now, in general, the females are larger than the males. So I should have said big girl.
Yeah.
Because it's certainly the biggest ones are female.
Mm-hmm.
But what's super interesting about them is how strangely little we know about them. They were first caught on camera in the 50s, and they were not caught on video until 2003.
Wow.
Yeah. They tend to like deep water, roughly between 2,000 and 4,000 feet below the surface.
Okay.
But they've been seen at depth up to 6,000 in the Gulf of Mexico and 7,200 feet below surface near Greenland.
Holy cow.
Yeah. And what is crazy to me about this is that they're ectotherms, so they're cold-blooded.
Sure.
It's cold at the bottom of the ocean. I think what I saw is between 1 degree and 10 degrees Celsius is where they're spending a lot of their time.
Can you Can you give that to me in my tiny brain in Fahrenheit?
1 degree Celsius in Fahrenheit is like 34 degrees Fahrenheit.
Okay, that makes sense.
And then 10 degrees would be about, see if I can do the math right. I'm thinking 10 degrees is about 45 degrees.
Okay.
Roughly.
That's pretty cold.
Yeah, and for water,
Yeah.
that's so cold. That's just above freezing. So how an animal that does not produce its own body heat can survive in water that is basically freezing, I have no idea.
I think this thing should be called the Scandinavian shark.
I mean, Greenland shark.
There you go.
We're close.
Yeah.
So because it's so cold, these sharks aren't the quickest. Take a guess as to what you think their cruising speed is. So not like their darting speed, not when they're swimming their fastest, but when they're just cruising around. I'll give it to you in miles per hour.
Historically, I haven't been great about this.
That's why I think it's going to be a fun game to play.
Okay. I want to say, we'll say 4 miles an hour.
For cruising speed?
Yeah.
You're not too far off. Their cruising speed is about 0.76 miles per hour.
That's a lazy stroll.
That's a lazy stroll.
Yeah.
Their darting, max out, miles per hour, is about 1.6. These sharks are pretty slow.
Yeah.
Which brings into my mind, what are they eating?
Right. How do they hunt?
Well, here's the thing. They've never been observed hunting in video or even believable text, which makes sense because they're thousands of feet below the surface.
Yeah, I can't imagine they've been observed doing very much.
No. So what scientists believe is that they might be primarily scavengers, but also there are suggestions that they're really good apex predators. In general, they're eating things like seals and fish and things that might sink to the bottom of the ocean. So they have specialized teeth that help them to cut like chunks out of the flesh. So instead of taking a bite and like ripping it out, they almost take like a core. They bite and take out a core of flesh.
Interesting.
They also have been, they can be a byproduct of fishing. So the most experience people have with them is being caught in fishing nets. They have found in their stomachs the remains of seals, which, like I said, not too out of the ordinary.
Sure.
Seals also only swim about 2 times faster than them. So it's possible that they could sneak up on a seal and catch it before it swims away. But they've also found remains of polar bears, bears in general, other brown bears, horses, reindeer, the whole body of a reindeer too, not just like a head or a leg, like the entire body of a reindeer.
Oh my God.
And my personal favorite, moose.
What?
Yeah. They found all of these things in the stomachs of Greenland sharks.
And of course, lutefisk and pickled herring.
Their favorites.
Yeah. They must be able to like travel interdimensionally or something. Or that is one very lost moose.
Well, that's the thing. Where are they getting all of these things
Right.
if they spend most of their time at the bottom of the ocean? I saw, this is not scientifically supported, but I saw a report from biologists in Norway who said they saw one charge out of the water and grab a reindeer. So in the way that you think of like a Nile crocodile waiting below the surface, and then as wildebeest approach, they launch out and grab it. They said it was very remnant of that.
How far? So like how far onto land could they get?
Not very far. Maybe a couple of feet. It didn't specify. But still, what?
That's nuts.
buckle in, because we still got stuff to talk about with these guys.
I don't see what else there could be, but go ahead.
They have poisonous flesh, so humans could not eat them. Humans will die if we eat them. Eating their meat causes symptoms similar to severe drunkenness.
Don't put that out there.
Before death, let me just clarify. It's extreme drunkenness and then death. There have also been reports of sled dogs getting into their meat and then not being able to stand up for hours. Again, extreme drunkenness.
Wow.
The dogs were okay most of the time.
Good. That's all I care about.
But they have high concentrations of trimethylamine N-oxide, which builds up in their flesh because they're at the bottom of the ocean. So they use it to help them keep buoyancy and also hold up to the pressure. And most sharks are going to have like oil compounds in their skin and in their tissues to help with buoyancy. But this one just has so much that their flesh is deeply toxic.
Is that just because it's so deep in the ocean, presumably?
That's the suggestion. But like I said, we don't know a whole lot about these guys. So the last thing that I really want to talk about is the reason I brought up the Greenland shark in general. And it is because of the fact that they are often, if not always, in certain areas, victimized by a parasitic copepod.
Oh.
So a copepod is a small crustacean that they live in nearly all bodies of water, freshwater and saltwater. They're these tiny crustaceans. To bring it into the pop culture realm, plankton from SpongeBob is said to be a copepod.
Okay.
And they look pretty similar. They have one eye, they have antenna, they're small crustaceans.
Sure.
The copepod that's parasitic to the Greenland shark is Omatacoida elongata.
Sounds like a nasty little creature.
Yeah. They seem to be about 1.2 inches long, sort of the general range I got. They're about an inch. They're tiny.
Yeah.
But they attach to the cornea of the Greenland shark.
Ah.
Not something I want in my life. Anything touching my cornea,
No.
let alone a crustacean attaching to my cornea.
Yikes.
Now, this crustacean severely impairs their vision and a lot of times makes them completely blind. In certain parts along Greenland, researchers found that about 1,200 of the sharks they found, which was about 85%, were affected by this. In other parts of the ocean, it's lower, but again, nobody knows why. There are suggestions that the parasitic relationship is actually mutually beneficial.
Huh.
And it seems to be, there was a theory that O. elongata, that copepod, was actually bioluminescent and that it could lure fish to the head of the shark with its bioluminescence, so almost looking like a bioluminescent worm, and causing them to be able to lure these animals in before eating them. But there is some unpublished data that suggests they're not bioluminescent, which then brings the question around, which is, so why do they attach to the eye? Because it seems like they must be getting some sort of nutrients, but scientists don't know what it is. And also, they have blinded a shark that is still somehow able to eat reindeer and moose and polar bears. They're still highly successful hunters and scavengers, even though they cannot see.
That's crazy.
Here's a little silver lining. There is no record of one ever being a predator of humans. There's no record of a Greenland shark eating a human.
Well, initially that was my first thought, is like there's no way that they're preying on humans because they're living so deep in the ocean. But apparently they're jumping up on land and snatching prey
Again,
out of the woods.
An unsubstantiated claim, but still...
Oh, and that was just like somebody saw it?
A scientist saw it. So you can't completely discount it, but also there's no pictures and not a whole lot of other information.
Okay.
But still, it's catching animals.
Yeah, it's got to be.
And the remains that they found in the stomachs were not decomposing remains. They weren't, or the bodies hadn't been decomposing before the animal ate it.
Okay.
So it did somehow get a reindeer, get a polar bear, get a moose.
Wow.
Even though they spend most of their time in the deep water.
But they don't attack people.
But they don't attack people because they like cold water, and not a whole lot of people are swimming in water that's just above freezing.
That's fair. It's funny that you bring up copepods because I'm actually going to talk about that a little bit later in my segment.
We planned this, everybody. We coordinated.
Yeah.
We knew we were going to be doing these things.
Shh, don't tell them our secrets.
But yeah, we need to do more research on Greenland sharks. If you like sharks or fish or even anything in that realm, please dedicate your life to studying Greenland sharks so that I don't have to.
How there has to be like a Shark Week segment on this or something.
I mean, you'd hope so, but like I said, I could not find a whole lot of information.
That's bananas. We're going to have to Google that.
So coming from our talks about Greenland sharks and the parasitic copepod that attaches to their eyes, horrifying.
Yeah, stuff of nightmares.
This led me to our main topic today, which is absolutely going to be the stuff of nightmares. Our main topic is parasites. And not just any parasites. Parasites that change the behavior of their hosts.
Oh my gosh.
Zombie-like parasites. Don't worry, most of them do not affect humans.
Okay.
But hang in there because some of them do.
Oh my gosh.
I've mentioned this before. I love diseases and parasites and the ecology of everything that can kill you, basically. It's so interesting to me. However, if it gives you the heebie-jeebies and you're not Reese, feel free to skip ahead to his segment this week.
Yeah, I'm stuck here. And by the way, it does give me the heebie-jeebies.
Yes.
So I'm along for the ride.
He is my captive audience.
Mm-hmm.
Okay, so what we're going to start with is something called a horsehair worm, which I think is probably the grossest to me, which is why we're starting there. Little worms that whip around, not my jam. So horsehair worms infect crickets and grasshoppers. If you've ever stepped on a cricket and seen a little worm wiggle out of it, that's a horsehair worm.
What? I've never seen that.
Oh, really?
That's what?
It's pretty common. If you've seen that, drop that in the comments because we'd love to hear about it. I would love to hear about it.
Yeah, you'll be fielding questions on this subject.
Yes. So horsehair worms can grow up to a foot long.
What?
Yeah. They're super thin. They're not like thick worms.
Somehow that's worse.
But it's called a horsehair worm because they look like horsehairs, like a tail hair from a horse.
Okay.
They can grow up to a foot long, and essentially they are born in water. And as tiny larvae, they are eaten by some sort of water bug, like a mosquito larva or a mayfly larva. Specifically, they go for mosquito and mayfly larva because both of those then fly out of the water. Mm. Once they leave the water, they are eaten by a cricket or a grasshopper because crickets and grasshoppers are carnivorous.
Sure.
They eat other insects. Within the body of that cricket, they grow up to about a foot, like I said. Oh. And then they alter the central nervous system from inside of the cricket. This causes the bug, the cricket or the grasshopper, to seek out water, which isn't something that crickets and grasshoppers typically do. They get their moisture from their food like a lot of animals, and they can't swim. So the horsehair allows the cricket to essentially drown itself. So it jumps into water, it drowns, and then the horsehair bursts from the body of the cricket and lays a bunch more eggs in the water.
That is just, you know what it reminds me of?
What?
That there's that M. Night Shyamalan movie where people just go crazy and start to kill themselves. And
I don't know that one.
It's like if you know what I'm talking about, put it in the comments because it's just like this.
It's horrifying.
These
are also called kamikaze horsehair worms.
Yeah.
Because they take over the body of their host and cause the host to kill themselves.
Nope.
Like I said, my least favorite.
Yeah, that one's rough.
All right. Now we're going to move on to two types of wasps. Because wasps, from an ecological standpoint, are super interesting. They're very diverse, and they've developed thousands of ways to have babies, to protect their young, and to make sure that their babies grow into full adult wasps. I'm not a huge fan of wasps on a personal level, but like I said, from an ecological standpoint, they're a very interesting group of insects.
Yeah, impressive. And very good at taking over the back porch.
Yeah.
Or the garage.
Stinging anything that comes near them.
They are really just the worst.
Buckle up. So the first one we're going to talk about is the ladybird parasite. Now this is between a wasp and a ladybug. So ladybugs are called ladybirds in other types or in other places in the world. I'm going to call them ladybugs. Before we go into it a little bit, I'm going to talk about aposematic colorations. So an animal that has aposematic coloration is an animal that has bright colors to warn predators that they're poisonous as a way to avoid getting eaten. That exists throughout the animal world.
Yeah, I think of like poison dart frogs.
Yeah, that was what I was going to say as well.
Mm-hmm.
But ladybugs are another good example of aposematic coloration. They're bright red or bright orange, and they have spots, which is something you don't typically see from an animal that is not poisonous in some way.
Are ladybugs poisonous?
Yes.
Really?
So if you have ever irritated a ladybug, you might notice that you get a weird smell on your fingers, or like the environment you're in gets a weird smell.
I tried to live and let live, so.
Yeah. I'm a very hands-on person, so I have had this happen to me. Ladybugs will emit this poison, and it's a good way to warn other things that you are poisonous and you are going to hurt them if they come near you. Wasps, this specific type of wasp, has taken advantage of that. So this wasp will sting a ladybug, and when it stings the ladybug, it leaves behind a single egg within the body of that ladybug. Now, within the body, that egg will hatch, and the larva eats through the abdomen of the ladybug.
Nope.
Once it's eaten through a lot of the internal organs, it will burst from the underside of the ladybug and create a cocoon between the legs. So the ladybug is standing on a leaf, the wasp bursts out from underneath and spins a cocoon, attaching themselves to the leaf and to the underside of the ladybug. This keeps them safe because if something approaches the ladybug, it will still twitch its legs and show that it is poisonous. So the larva underneath can be protected until they reach a large enough state to leave that body behind. You're going to hear a lot of grossed out noises from Reese.
Yeah, I just got itchy all over my body.
That's reasonable.
Yeah.
The craziest thing about this particular one is that 25% of the ladybugs survive this event.
Didn't you say that it eats their internal organs?
It eats through their abdomen, yeah. So ladybugs, way cooler than you thought before you started listening to this podcast.
Apparently. So wait, what's the purpose of them having those organs in the first place?
Well, I think they regrow them, is my understanding.
No kidding.
Yeah. Bugs or insects, if you're an insect lover, because I've been yelled at for calling things bugs in the past. Yeah. Insects are incredible. They are so good at surviving, clearly. And they also develop the weirdest interactions with other insects, as you're learning.
Yeah, finding that out.
Our next wasp is the emerald cockroach wasp.
Really just sounds like a terrible, terrible animal.
All of your favorite things. Wasps and cockroaches.
Yeah.
All spun into one. So with this one, the wasp will sting a roach, effectively paralyzing that roach.
Oh.
It then injects neurotransmitters into the cockroach's brain.
What, like a LoJack?
Yeah. Yeah. A little bit like a LoJack and a little bit like some psychedelic mushrooms that allow the cockroach to be controlled.
Yeah.
So the wasp injects these neurotransmitters into the brain of the cockroach, and that renders this cockroach completely helpless. Once it's succumbed to that, the wasp will chew off its antenna and uses it like a chariot. It can lead the cockroach anywhere. So there's this wasp, which is 6 times smaller than the cockroach, sitting on the back of this cockroach, leading it. The wasp leads the cockroach back to its nest, but not before sucking some of its cockroach blood.
Sure.
Just a little pick-me-up.
Yeah, right. You need a snack for the road.
Yeah, I get it. I'm a snacker. I understand. The wasp leads it back to its nest. It sucks some of its blood, and then it lays its eggs in the abdomen of the cockroach.
They keep doing that.
Yeah. Insects do that all the time. Lay their eggs inside of other things.
I hate it.
I don't love it either. But the mechanisms are so interesting.
Yeah, it makes sense.
So once the wasp has laid its eggs in the abdomen of the cockroach, it builds a barricade around the cockroach's body of stones, typically. Tiny stones, because it's a tiny wasp.
Yeah.
But just a little barricade to keep it from wandering off. Now, if you've ever seen a cockroach, they can climb anything. A little barricade of stones is not going to stop a cockroach from crawling out of this nest. But those neurotransmitters...
I was going to say,
absolutely will.
Yeah, if your brain doesn't work, then you're not going anywhere.
No.
Yeah.
So the roach just sits inside this barricade as the eggs develop. And when the eggs hatch, they eat the cockroach alive.
Good.
And it just sits there.
Sounds like just the worst way to go.
Yeah. And I am no fan of cockroaches. Especially if they're in a home.
Yeah.
But I don't wish that death on anybody.
I just imagine them like, I survived the nuclear holocaust for this.
Yeah.
Yikes.
The wasps will also survive.
Probably because of the cockroach.
They'll be inside the body of the cockroaches.
Oh, man.
So the next one we're going to talk about is one that affects humans. But the good news is it almost never affects them in a negative way. It's not positive either, but it's relatively neutral. The next one is toxoplasmosis, which you may have heard of. It's also called Toxoplasma gondii.
I've heard you say it before. I'm not sure what it is, though.
Well, I'll tell you about it.
Okay.
So toxoplasmosis, it is a single-celled organism, and it infects mice and rats. It is a single-celled organism that infects mice and rats.
Like an amoeba?
Yeah, like an amoeba. It's not an amoeba, but it is like an amoeba because it is a single-celled organism.
Okay.
Like I said, it's relatively well known. 30 to 60% of humans have it. If you have a cat that has ever been outside, especially a cat that you frequently let outside, you most definitely have it. In humans, it typically either is asymptomatic, so it doesn't really cause you any negative effects, or it causes mild flu-like symptoms. Like I said, a lot of people will get this in their lifetime, and most of the time, it's no big deal. When it starts to become a problem is for pregnant women, because toxoplasmosis can cause issues to developing fetuses. It's why if you've ever been pregnant and you have a cat, your doctor will tell you not to clean the cat's litter box.
Huh.
Because you can get toxoplasmosis just from cleaning the litter. However, we're not here to talk about its effects on humans because it doesn't alter behavior in humans. I mentioned that a big host for it is mice and rats. So mice and rats will ingest it from a food or water source. It just sort of exists. It's a single-celled organism. And it causes them to lose their fear of the smell of cat urine. So normally, mice and rats will smell cat urine, predator urine, and will try to get out of Dodge. They do not want to be anywhere near something that can eat them.
Logical.
Yeah. It's a good instinct.
Yeah. Run away from your biggest predator.
Right.
Yeah.
However, if it's infected with toxoplasmosis, it completely loses that fear. And in some studies has even shown to move towards cat urine. When you have mice and rats and you put them in an environment where there is cat urine and there is mink urine, which is another thing that will eat them, they will always go towards the cat urine if they're infected. And in some cases, they even seem to explore the smell of cat urine, even though in the past they've been exposed to cat urine and they know that it's not something that they should be around. This single-celled organism somehow allows them to lose that fear. Now, single-celled organisms do not have brains. They don't plan this stuff. So from an evolutionary standpoint, this is amazing to me because their goal is to be eaten. Toxoplasmosis wants to get into a mouse or a rat, and then it wants to be eaten by a cat because the cat will then poop out the toxoplasmosis into water sources and into grasses and into sands where it can spread into more wide hosts. Reese looks astounded.
As bonkers. So how?
I could not figure that out. I read a bunch of papers. I looked at a bunch of stuff. And they think it relates to certain immune responses and brain responses. But in general, we don't really know. And that's insane to me.
Yeah.
Wow.
Yikes.
We're not done yet, though.
Oh,
we got more, folks.
But wait, there's more.
The last one that I want to talk about in detail is called cordyceps. Some of you may have just had a reaction to this because you might already know what it is. Reese is not one of those people.
No.
It's also called the zombie ant fungus.
Oh my gosh.
So cordyceps are fungi. And they will produce spores, which is how fungi reproduce. It's how they spread. It's like a seed, but for fungi. And these spores will attach to the body of an ant who's just going about his business. They're walking around, picking up leaves, bringing them back to the queen. Basic ant stuff. Once the spore gets into the body of an ant, it manipulates that ant into climbing up a tree. So instead of that ant following its course back to its safe haven in its anthill, it will instead drop what it's doing and climb up the nearest tree. There was a 2009 study that showed ants that have been infected with this cordyceps fungus will always go to similar points on that tree. They walk about 25 centimeters up the tree, to a location above the ground that has the perfect humidity for that fungus to grow, the cordyceps fungus that is inside of the ant. Once they get to that point, the ant will bite down on a leaf, engage its mandible, and die 25 centimeters off the ground.
How does it die by doing that?
It just dies.
Just power down?
Power down.
Yikes.
Because the cordyceps is controlling its brain and taking over the inside of the body of the ant.
Oh.
But this isn't the end of the story.
No, of course.
At this point, once the ant is dead, within about 24 hours, fungal threads, which are basically exactly what they sound like.
Yeah, horrible, you mean?
Yeah.
Yeah.
Fungal threads emerge from the body and just sort of start reaching out places. Now, again, still not done. There is a final coup d'etat that happens where a stalk, a fungal stalk, so if you think of like a mushroom popping out of the soil, that is a fungal stalk. Except for this fungal stalk emerges from the head, like explodes out of the ant's head, and rains spores on the forest floor.
Oh my gosh.
Ready to infect another ant. These things are so cool, and I encourage you to find a YouTube video of the 24-hour process as the spores and fungal threads are coming out of the ant's body. It's horrifying.
Forgive me if I pass on that activity.
If you're listening, do not pass on that activity. I promise you it is worth it, and not nearly as gruesome as it sounds.
Okay.
Before we wrap up our talk about parasites, because I'm sure we'll do this again, I wanted to shoot an honorable mention out to rabies. Who doesn't love rabies? Reese raises his hand. Everybody hates rabies, rightfully so. Rabies can affect nearly all mammals, and it's spread through saliva. So a lot of times, scratches or bites are a good way for rabies to spread. Now, in general, it seems fine, kind of innocuous, except for it causes people and animals to become aggressive. It engineers them to a point where they're trying to bite other things. They're trying to spread the rabies virus. This should be terrifying for everybody. We should all have our rabies vaccines. Our dogs should have their rabies vaccines because this is not a good way to go. Your entire body basically shuts down, you go crazy, and you lose the ability to eat or drink. So you waste away, angry and horrified at what you have become. And for the ability of a virus to do that to multi-celled, highly advanced organisms with highly advanced central nervous systems like mammals is incredible and terrifying.
Yeah. So why is that an honorable mention?
Because it's the only one I could find that really affects human behavior. So it's an honorable mention because it's doing something that not a whole lot of other things can do. And that's, terrifying as it may be, so interesting.
Yeah. Today we're going to talk about bioluminescence.
Bioluminescent algae.
Well, that too. Actually, no. I don't think I got any examples of that.
That's okay. Watch Moana and you'll get an example.
Is it Moana or isn't that Life of Pi?
There is bioluminescence in Life of Pi, but I'm talking specifically of Jermaine Clement as the giant crab.
Oh yeah.
Talking about the bioluminescent algae.
That's right. Yeah. That's a terrific example, and I hadn't thought about using that.
Well, you're welcome.
We probably can't get the rights.
There's no way we can get the rights. But anyways, teach me about bioluminescence.
Cool. So bioluminescence is something pretty much everybody's familiar with. I'm sure if you don't know the term, at least you're familiar with the concept. It's a form of chemiluminescence, which is the emission of light as the result of a chemical reaction. Makes sense. This is different from fluorescence, which we covered last week, or phosphorescence, which is similar to fluorescence. They're just different methods of the same thing. But chemiluminescence is different because the electronic excited state is the product of a chemical reaction rather than the absorption of a photon. So you'll remember in our last episode, we talked about how certain atoms absorb rays or energy and re-emit those. This isn't that. This is light being emitted because of a chemical reaction.
Okay.
Forensic scientists also apply this using hydrogen peroxide and, can you guess the other chemical?
Oh. I'm racing through my mind. Is it vinegar?
No.
Am I close?
No. It's something you definitely know, and I've heard you say it before.
Hydrogen peroxide. I'm picturing it in my brain because I've seen the YouTube video where somebody makes himself a glow stick out of hydrogen peroxide and something else.
I don't know if this is necessarily that, but it might be.
What is this?
Luminol.
Oh, no.
Yeah, how could you get that one wrong?
If you're unfamiliar and have never watched Forensic Files, what is it called? Who's the one doing the talking?
The narrator?
Announcer. Narrator. The narrator of Forensic Files says the word luminol like 400 times an episode. That's an exaggeration, but it feels like if you're watching that show, you hear the word luminol a lot.
Yes, it's a very popular chemical apparently with forensic scientists.
It can be used to find body fluids.
Yep. So anyway, I just wanted to throw that in there because I thought you'd appreciate it.
I'm mad at myself for not figuring it out.
I know. I threw you kind of a softball one there, Kels. It's okay. It doesn't actually really apply to what we're talking about today anyway. So bioluminescence is the production and emission of light by a living organism through that chemical reaction. So it's generally a chemical reaction involving a light-emitting molecule and an enzyme. This is a process that I don't understand that well because I'm terrible at chemistry. But apparently the compound or the molecule that is the light-emitting compound found in this reaction is luciferin.
Okay, is that true with all animals or all organisms?
Well, so it's a generic term.
Okay.
So yes, all animals basically, the molecule is going to be luciferin. The enzymes are going to be called luciferase.
Got it.
So those are the two generic terms. Sometimes they involve outside compounds in the reaction. Some of it depends. A lot of times bacteria is involved too. But the specific type of luciferin and luciferase is categorized by species. So firefly, luciferin.
I see.
It's used for a lot of different things depending on the animal. Camouflage, mimicry, and communication and signaling between species.
Can it also be used in predation?
It can. So a couple of examples of animals that use this. There are some deep-sea squid. The firefly and the midshipman squid are common examples, and they use it for counter-illumination camouflage.
How does that work?
From my understanding, it basically redistributes. So presumably they're in the deep sea and light sources. There's like ambient light and there's this bioluminescent light. They use it to confuse predators or prey. I'm not sure which one it is with them, but confuse the other animal as far as where their actual outline is.
Makes sense.
Yeah.
So it ties into sort of the aposematic coloration that I mentioned earlier. I don't know if it's technically the same, but in a way where they're using this coloration either to warn a predator not to eat them, or as you said, to confuse.
Yeah, I think it's kind of in the opposite way. I think it's in the confusing the predator as far as where they are.
Okay.
Or what their specific outline is, or even what type of animal they are. There's an example I'll get to later that uses that a little bit too, in a different way. So the one that probably comes to everybody's mind, or at least my mind was first, is fireflies. And they use it for attracting mates. So you'll see that whole, which I guess I never thought of that. I just thought they were, flying around and they just light up. But apparently they're all out there at some big social gather, like the Firefly Club, and they're all dancing and trying to holler at each other with their light up butts.
Sometimes I get upset that I am a human being and that we do not have such interesting dating rituals.
I know. Next on the list is cephalopods, like squid, or I think crustaceans. Do crustaceans fall under this too?
No.
No? I thought
Cephalopods are like squids and octopus. You might be thinking of like a conch.
Okay.
A conch, I think, is also a cephalopod.
Okay.
But no, crustaceans are crustaceans.
Okay. They're another category.
They're their own category, yeah.
Okay. Well, see, you learn something new. So cephalopods use it a lot of the time as a distraction, similar to how other squid or octopus would use ink. Do octopus do that too? Or is it just squid?
I think it's just squid.
Okay.
But I don't know.
Anyway, I apparently know nothing about cephalopods other than they're freaky and they're awesome. So they use it as a distraction, similar to ink. It confuses the predator while the animal has a chance to escape. It's basically just like bioluminescent ink, but I think it's a bacteria mixture, something like that. And they just shoot it out. Predator gets confused because the light's going everywhere, and the squid swims away.
Wow.
Yeah, a really cool example of this is the sea firefly, which is, have you heard of this?
No, it just sounds awesome.
I know, it's super cool. Apparently they're really common in Japan, and they're by the shore because they nest in the sand, and they basically, when they try to get away, they shoot out like the bioluminescent, whatever material, and it puffs up with all the sand and the sediment and creates a cloud that confuses the predator, and then they get away. Where it gets super cool is you can see pictures of shorelines in Japan at night where there's just all of this blue material, like up and down the coast. It's super cool, and we'll attach a picture of that too.
And that is from that sea firefly?
Yeah. Yep.
Just from shooting up their little bioluminescent ink defenses?
Yeah, exactly. They shoot it up in addition to the sediment, and it creates like this big cloud.
Wow.
Right. Isn't that cool?
Yeah.
Yeah. Since I had never heard of it, apparently it's tiny.
And probably adorable.
Yeah.
If it's tiny.
Yeah. They're kind of weird looking. They're like see-through, and, they're cephalopods, so they're weird sea creatures, but...
Tiny krakens.
Yeah. That being said, they're pretty adorable. Next up is pyrosomes, which are super cool. I had trouble kind of understanding how this worked at first. So apparently it's the animal is considered the whole colony. They're known as colonial tunisates. Did you know if that's how you say it?
Sounds right.
Sure, we'll go with it. Colonial tunisates, which are invertebrate animals, but they're made up of a collective of these little individuals.
Almost like coral.
I guess, yeah.
Because coral is a bunch of colonies.
Yeah.
Banding together.
Yeah, I would say that's accurate.
Okay.
I don't know if this is how it works with coral, because it seems like it'd be a little more it's not like a free-floating animal. Never mind. I don't know enough about coral to say if it works the same way.
Okay.
But each individual in the colony has luminescent organs, and they blink in response to other individuals in the group and even in nearby individuals. So like other actual animals, other pyrosomes, I should say. The crazy thing about this is there's no neural pathway between any of the individuals. They just blink in response to each other. And they use it as communication. There's a lot of reasons that they use it for communication, but it helps in primarily their colonial function. So this is like how they can communicate with each other and function basically as one animal.
Wow.
Right.
Are they connected to anything, or are they free-floating organisms?
They seem like they're sort of free-floating. Maybe it depends on the type of pyrosome.
Okay.
There's some crazy pictures. They're really bizarre. They look like aliens, pretty much.
The ocean is so big, and there's so much weird stuff in there.
There really is. The craziest thing I think about these is, or how they use that, is in their propulsion. So like the way that the animal swims as one animal is through this communication, and each individual within the animal has a different propulsion role. And together they communicate through the blinking and propel the entire animal as one. Isn't that nuts?
That is just so bizarre.
Yeah.
And in my mind, it's almost as if it lends credence to the idea. Lending credence isn't exactly what I mean, but it makes me think of how scientists many moons ago thought the brain was a bunch of tiny versions of people, like controlling the body.
Yeah.
And you see it a lot in cartoons where it's much more literal, and it's like a command center inside the brain.
They're all pulling the levers.
Right.
Yeah.
It seems like the real world application of that concept.
Yeah.
Which
Pretty
is
much.
insane.
Yeah.
It also reminds me of yeast.
Yeah. How so?
Yeast can function as a multicellular organism, even though yeast itself is a single cellular organism. So single cells of yeast can band together, and as a group, the cells start behaving in a way that benefits the group but not the individual cell.
Yeah.
Just to sum it up really succinctly.
Cogs in the machine.
Right.
Sort of. Yeah. That's crazy.
But for them all to be their own organism, banding together and working together.
Yeah.
Those are the people you want to hire at your company.
Yeah. That's right.
A+ teamwork.
Yeah. Seriously. And the fact that it's possible through that type of communication, the bioluminescent communication with no neural pathway, is insane to me.
A+ communicators, too.
Yeah. Oh, yeah. They all can put that on their resume.
Yeah. I'd hire them.
Yeah. So next up is anglerfish, which that's another one that jumps to my mind when I think of bioluminescent animals.
Oh, yeah, because the anglerfish are the ones that use bioluminescence to lure prey in, right?
Oh, yeah. That's how they get their name. So they have an appendage on their head called the elysium. I think that's how you say it, which is basically like this big sort of fleshy rod thing that sticks off the top of their head. And at the end of that is something called the esca, which is a cluster of bacteria, basically. Like it's a little bulb that has bioluminescent bacteria in there, and the fish can control the glow to lure in its prey and then eat it. Obviously, it's prey. But the crazy thing about it is the way that this works, and they don't know exactly how it works, how the anglerfish gets the bacteria to participate in this. I imagine there's probably something beneficial there. It's a symbiotic relationship. But apparently they enter through basically these pores in that little bulb. They go in there, and then once the bacteria is in, the anglerfish can control the glowing.
So it's basically like a controllable zit.
Yeah.
Wow.
Yeah. Which is nuts.
Do you know how they control it? How they control the light quality?
No. From what I understand, there wasn't a lot that is known about that.
Which is logical. They live at the bottom of the ocean.
Yeah.
They're hard to study.
Right. And I'm sure there's more out there that I don't know or understand. I only did a little bit of reading on it, but it's pretty crazy. I never knew they could. I mean, I guess I sort of assumed they could control it, but I never knew it was separate from the fish.
Yeah.
Yeah. Isn't that crazy?
Wow.
So it's a form of aggressive mimicry, sort of what you were talking about earlier, where like predators will camouflage themselves as another fish or camouflage their shape to lure in prey, which is just crazy.
Good thing we have fully functioning brains for the most part.
Yeah. And we're not just lured in.
Most of us, I guess. Multi-level marketing schemes are doing really well right now.
Yeah, they're the sort of the 21st century anglerfish. Another good example of this is barbelled dragonfishes. Barbled?
I think it's barbelled.
Barbelled. There's only one L, so I wasn't sure. Yeah. So the way that they do it, they have these little patches under their eye that emit a red glow. They're one of the normally when you see bioluminescent animals, especially in deep sea, it's almost always blue because that's the light that can filter through at that depth in the ocean. This allows the fish to see red pigmented prey at those depths.
Wow. That's a big deal because I know a lot of fish and things at the bottom of the ocean, like lobsters, are red colored for that reason that you said, that the light cannot penetrate. So the light that allows red wavelengths to be seen doesn't penetrate that far into the water.
Right.
So if animals are red, they're less likely to be spotted.
Exactly. Right. And a perfect example of this is a copepod.
Oh, hey, back to the beginning.
It's all cyclical. The circle of life.
The one health strikes again.
Yeah. One of these fish, I don't know if it's technically a barbelled dragonfish. I think it is. I can't remember. But it's called a northern stoplight loose jaw.
Long name.
Yeah. It goes by some other colloquial names. But first of all, it's a crazy looking fish. The reason it's called a loose jaw is because it can basically unhinge its entire jaw and like reach out and snap in its prey from like a great distance. So it's freaky looking. The mechanics of that, like it almost dislocates its neck and entire head when it does it. It's crazy. But it produces a red glow. And copepods are its main prey. So it produces a red glow, but the eyes aren't sensitive to that wavelength. A lot of other eyes, like other animals' eyes at that depth, are not sensitive to it either, which is part of what makes it effective because it allows them to see that red light without alerting predators, which makes it a very effective hunter.
So they can hunt using basically a flashlight that nobody else can see.
Right, including them. That's the crazy part. Their eyes shouldn't be able to see it, except that they have an additional retinal pigment that fluoresces blue-green. So it's like their eyes have this special adaptation that filters the red light somehow. As far as I understand it, this could be totally wrong. But it filters that red light somehow, and it allows them to see those red wavelengths as like blue-green. You know what I'm trying to say?
Almost like a blue-green light.
Yeah, like a flash. Like it alerts as blue-green in the retina, I think.
That'd be where?
Yeah. Yeah. Okay. In their eye. Long story short, they can see it even though they shouldn't really be able to see the red wavelengths, which is nuts.
Incredible.
Yeah. And that's how they catch the copepods.
It's crazy how nature can do these things.
I know. All these adaptations are just nuts.
And we're stuck with this weird fleshy prison. Why can't my eyes light up?
I feel like we have some pretty cool features too, like our brains.
Yeah.
Yeah, some more than others, I guess, but still. Last example of one of these animals is called the barrel eye.
Heck yes.
Yeah. This one, I just saw this, I think, recently on like a Planet Earth or Blue Earth or something.
Blue Planet?
Blue Planet, yeah.
Which, if you have not seen it, this is not an ad. If you haven't seen Blue Planet, stop listening to the podcast. No, I'm kidding. Finish the podcast.
Finish the podcast.
Then go watch Blue Planet.
Yeah. And you'll see the barrel eye on there because it's the weirdest looking fish I think that I've ever seen. They have this dome over the front of their head where their eyes are, and they can point their eyes are shaped like barrels, which is where they get the name. And that can point up and forward. So they can move it around in there, and they can see all through that clear dome. And that dome is filled with fluid, like a clear fluid. So they can just see at like 45 degrees, 90 degrees almost, I think.
In my head, it's almost as if the eyes are like a cannon, and the cannon adjusts straight, and then you can, straight as in parallel to the ground, and then you can adjust that cannon to shoot perpendicular to the ground. Mm-hmm. Is that essentially what they do?
Yeah. So it's a lot of times the way that they do it. So there's more to how the eye functions. Their eyes can distinguish between ambient and bioluminescent light, which is a big deal because they're not going to be as easily confused by bioluminescent light from their prey.
Do they eat things like cephalopods that use bioluminescence to confuse their prey?
Yeah, I think so. I'm honestly not that sure about that one. I'll have to check. But they do eat, from my understanding, bioluminescent prey, at least. And the way that they do that, I think plankton is their main target because apparently they hunt from below, so they point their eyes up, and then they can adjust so that their eyes are facing the same direction as their mouth, and they have these really big fins that allow them to swim really accurately. So they can, I don't know that they're extremely fast, but they're pretty fast and stable and precise. So they can sneak up basically on these animals. But they're the goofiest looking thing. I'm not sure exactly what part of them is bioluminescent. I think inside the dome there is something. All the pictures that I see makes it look like that. But I also read other places that they have some reflective or bioluminescent organs on their belly. And what that does is protects them from other predators. And it's a form of that counter-illumination camouflage.
So they're using counter-illumination camouflage to keep themselves safe from their predators, but they're also using these really cool adaptations to be super effective hunters of other animals that use bioluminescence.
Mm-hmm. Yep, exactly. So because of their highly specialized eyes and the way they can adjust them, they can filter out and determine with the actual shape of an animal.
Do they have a lack of skull? Like, is there a skull bones? Are there skull bones that are missing so that they can inflate this head sac with fluids and move their eyes about?
I think so, yeah. That's kind of the difficulty with observing this fish, is that there's only, I think it's the Monterey Bay Institute of something. You might know that better.
I think it's just the Monterey Bay Aquarium.
Yeah. There's a longer aquatic institute or something like that.
Okay.
But they've been the only ones successful, as far as I know, to actually get one of them up above the water and study it. Most of the time when you find them, that chamber collapses because of the change in pressure, I think, coming up.
The bends?
The bends, exactly. So they're sort of still a mystery. I think the first one that was captured on video was like 2008 or 2009.
Today's podcast has been a collection of wonderful nature mysteries.
Yeah.
It's been a critique of the scientific world, I would say.
Yeah.
We know a lot of things, but we don't know even more things.
Yeah, there's still a lot we don't know. And it's cool that we are still getting to see some of these brand new discoveries.
Yeah. That's one of those things I felt as a kid as though we had reached a point where we knew most things.
Yeah.
We were too old to explore the world and even most of the ocean, or we had been born too late to do those things. But we were born too early to explore space.
Yeah.
So we fall into this weird middle ground where I felt as if we weren't going to make any new discoveries, but that's not true.
Yeah, I'm sure. I think every generation probably, or maybe not every generation, I would say, probably feels that. I'm sure in the 1800s, they pretty much felt like they had discovered everything.
That's fair. It also, too, it's crazy to me that it isn't just oceanic animals.
Mm-hmm.
They just discovered a species of Galapagos tortoise that they thought went extinct 100 years ago. They just found it on the island and it's doing fine. Which I have a question about that.
Yeah.
How do you not know that there's a tortoise on your island that's alive and well?
Yeah.
For 100 years.
For 100 years. That's a long time. Maybe we're just bad at looking.
Well, there's some truth to that.
Not that I should. I'm not anyone to criticize the scientific community.
But it is crazy that we are still discovering these things.
Yeah.
And we're refinding things.
Mm-hmm.
I mentioned this on the IUCN podcast that every time the IUCN does another evaluation, we discover or rediscover 2 species that we thought were extinct that aren't extinct.
Crazy.
Which is great news.
Yeah.
Focus on the positives.
Yeah, really. Well, bioluminescence, I think, is super cool. First of all, it's just the craziest looking thing.
And a good testament to how interconnected everything is.
Mm-hmm. Yeah. It also, what I wanted to say earlier, too, was it also demonstrates really well a lot of those symbiotic relationships. Because a lot of these deep sea animals that are bioluminescent are that way because of their relationship with bioluminescent bacteria. And so it reminded me when you were talking about it's the one that attaches to the Greenland shark.
It's a copepod.
Copepod, that's right. It reminds me of those symbiotic relationships where it's, the only way that they can function and have that light and be able to hunt is through their relationship with this other animal.
Wow.
Which is crazy. That's more than I thought I was going to get out of it when I was looking into bioluminescence. I just thought it was a bunch of really cool glow-in-the-dark stuff.
And boiled down, it is a bunch of really cool glow-in-the-dark stuff, but I think that the details that you went into are the much more interesting piece.
Mm-hmm.
The way that they are interacting and the way that they're using this ability. Not only have they developed this ability, they're using it in a bunch of different ways.
Right. Yeah, and it manifests itself differently in each animal, and that's why they have to they can't just say this is the enzyme or this is the molecule. Like, they basically just have to say this is it, but it's specific to this animal.
Yeah. Crazy.
Yeah, crazy. But that's all I've got. Do you have anything else?
No, just once again, let us know if we're wrong.
Yeah.
Correct us on things. Shout out to us on Twitter, Facebook, Instagram.
Yeah, we'll look up some of those. I'll look up some of those questions you had for the upcoming corrections too.
And I'm sure the upcoming corrections is going to be chock full.
Yeah, they're going to start to get longer and longer as we tackle more difficult topics.
And get lazier.
Yeah, yeah, right. All right, well, if that's all you've got, Kels.
Yeah.
I'm Reese.
And I'm Kelsey.
And this is Charismatic Megafauna.